So I got in trouble when I tried to do one of these more challenging questions in class because this is the extent of the example problems that are in the OpenStax book, and none of them did exactly what I was hoping for. I really like a more challenging logarithmic equation. The reason I say that is because for all of these, um, like there's very few exceptions, but for all of these, we can see almost every one of them has logs everywhere. Right, there's no like the only one that doesn't have logs everywhere, 46, but that's a straight rewrite question. Um, Anything else that doesn't have logs anywhere? Yeah, these are a little boring to me, because honestly, we'll just go ahead and grab a couple of these. Something like 36, we can have the ln of 10 minus 3x is equal to the ln of negative 4x. This is already ripe for the one-to-one principle, right? That's even what it says, use the one-to-one property. So we can recognize since ln or all logarithms are one-to-one functions, whatever, if these two have the same output, they must have had the same input. So we can just set the two arguments equal to each other and solve. And I'm not even going to finish solving that equation because it bores me, frankly. One thing we do need to be careful about with logarithms, and so it's a good thing actually that I finished this problem or at least think about it, um, is that we need to make sure that whatever we get out as an answer is within the domain of a logarithm, right? So for this one, we know x has to be, not x, but the input, the arguments of each of these has to be greater than 0. So we could look at these two different things. For this right side, x has to be greater, less than 0. I see that. I see that that reflection. And in the second one, x has to be less than 10 over 3. So we have these two restrictions. And so if our answer is not within that range, within that domain really of our two, then we're not going to be able to use it. So it is possible to write an equation where there are no solutions to a logarithm. So you do want to check. But this is why I'm bored of these questions. Even when we come into something where they're like, ooh, look, 38, there's 3 logarithms now. Still bores me, right? If I did 38, the first thing I need to do is, like we said in the previous section or previous video, we got to do some combining. Right? If I could combine those two logarithms on the left side, then I have a log equal to a log, and I can just pop out those arguments. And we know, oh, look, there's subtraction going on between them, which means that we're dealing with the quotient property, the quotient rule. So we could go ahead and rewrite this as log of x plus 3 all over x, because it's minus x, is equal to the log of 74. And now we've got a log equal to a log, and we can just set the two arguments equal to each other. X plus 3 all over x is equal to 74. And so something like this, we would then want to figure out how to finish solving, right? This is a rational. Even though multiplying both sides by x is a little bit sketch, we just have sort of a note in our head, x cannot be equal to 0. And then we multiply through both sides by x. We get x plus 3 is equal to 74x. So 3 is equal to 73x, and x is equal to 73 over 3. So that's why. Oh, I thought I was frozen. I'm not. I just pause. That's what I do with my own. As soon as these things stop working, I freeze because I'm so used to it. Why? Hold on. Jamboard's acting up. Okay. You can do this. I believe in you. All right. 73 over 3. Um, I've already forgotten. Oh, yeah, every one of these questions, I immediately see like, okay, 39 might be a little more challenging because it looks like I'm going to get a quadratic as my resulting equation, whereas 36 and 38, well, 36, I ended up with a linear equation. 38, I ended up with this rational equation. 39 looks like I'm going to end up with a quadratic equation. Same thing with 42, a little quadratic equation. But in general, these are all just do the most basic combination possible, and then pop out your arguments because their sides equal to each other. And And that's true for everything on this sheet. The only one that doesn't have the logs on both sides is 46. So for this one, you would have to rewrite 2 to the 3 is equal to 7x plus 6. And now we're just back to a linear equation. So the examples in the book were a little lame. I like a little more challenging example. So I'm going to go dredge one up, not from the OpenStax book because it's too easy, and we'll do that in our next video.